Hey everybody, it's Dark Guards and we're back with another video. So I want to do a really quick video to talk about the automated testing that we're working on for the atomic science mod, particularly for the particle accelerators. Some of you kind of seen, we've only done a few streams and videos about the particle accelerator so far, and progress has not been very fast. I said I was going to get done by the end of the year, but stuff kept happening, I got a job, etc. So that kind of delayed the whole progress of it. But what's also kind of slowing it down, I wouldn't say slowing it down in a negative way, because this is actually kind of good, is we're doing the automated testing to ensure that in the future, as we keep going, we know for sure that things are going to work the way we expect them to work each and every time we make a release. Not just a release, if we make a change, or we add new content, or we adjust things, or balance things, we know from the automated tests that the logic that we have built in the past will continue to work as expected, so that way when it does get into the game and you do use it, it will function the way it's supposed to function without having to run into random issues like you turn the pipe this way or you connect to this configuration or order and all of a sudden it just stops working. So that's one of the things I've actually been doing, and I've been posting a little bit on Twitter and everything else of kind of the little progression of that. And I want to kind of show it off of kind of what we've got here. So this kind of started as I needed some way to test the motion. So for the particle accelerator, for those who don't know, let me go ahead and launch it up here. So I'll go ahead and hit debug and launch the client. So I'll do that while I continue to talk. Is that we kind of built the pipes, and we needed a way to test how the pipes were functioning. We couldn't just do this in game, because we had built up some of the content, we had built up some of the visuals, we got it placed, we were working on some of the connection code, but it wasn't really there. There wasn't enough to make it fully usable. And of course, like, when I've got free time doing other things, I can't always just launch Minecraft to do more work on this. But what I can do is write little bits of code to test various pieces. And one of the pieces I started with and started testing was the motion. I needed to know if a particle entered from one side of the pipe, how would it move through the pipe and exit out the other end, and how could I predict that and make sure that that worked the same every single time. Obviously the answer is just writing the logic so it works that way, but I needed a way to guarantee that that's what's going on, so we built unit tests to test various things. So we got, for example, right here, this is the particle movement for corner left. The only thing this does is test when we have a left bend, so just a little corner in the tube, that takes the particle that was going forward and makes it take a left turn. Very simple in concept. You would think, hey, we could just load up the game and test this and make sure it works, which we obviously can. But now we have a little bit of code that will run and will actually check each and every part of this. Now this is some of the older code, so some of the people that actually know a bit about JUnit testing will realize this is not the most effective way to do it, but kind of building up in tiers, and I'll kind of explain that as we go. So for the first test, we were just testing something like north facing forward. We were checking if we placed a particle in the very center of the tube, and this tube was facing north, will the particle travel north through the tube and exit? Or in this case, just move one step forward. So this just checks if it just moves. So we run a single update of the particle, which causes it to move one step. In this case, would be 0.1 meters, or 100 millimeters, I think. I don't, metric system is still not something I know. And it'll check to say, hey, are we still in the tube? Did we not move in the other directions? Because we only want to move in the z-axis. We don't want to move in the x, we don't want to move in the y. And then we check to make sure that we actually have moved the distance we want to do. And it does this for each rotation, and I have more effective ways to do this now than doing this per side. So there's a lot of like duplicate code here that you can see, and as I show some of the tests, you will notice it becomes less and less duplicated. Earlier tests are always going to be that way. And we test other things. So we test incoming. So like if we're facing south and we're getting a particle that's coming in from, in this case, the west, we can test that it comes into the tube, and then it actually does what it's supposed to do. It moves one step forward. And then we get down to the bottom down here where we have exit test to test if it can exit the tube properly. And then we have full motion. We test to see if the particle entered from one side, will it go through, take a turn, and exit? Simple logic, but with having this, I know that every single time we make a new build, that this will work each and every single time. And if we actually run this, which it won't really do anything special if I run it, but it'll tell me that this actually succeeded. And if I run this in debug mode, we can kind of see how the stuff works, which is another advantage of doing unit testing. If we do have a bug and we catch it real early in development, I can come in here and go, hey, our north-facing full failed, but all the other directions are working. What happened with this exact configuration of the tube that caused it to fail? I can come in here, I can run debug test on this, and it will come in here, and we can sit here and we can watch what it does. Once it gets to a point, it will actually do this. It's sometimes a little bit slow bearing stuff that happens. But we can see our particle created. In this case, when the particle actually does create, which I should have showed this actually working, is that it actually does create a particle. It sets the speed, it sets the facing direction, it sets it on 0, 0, sets the dimension, it sets the current node on it, which creates a brand new node. The nodes themselves actually have some validation on them, so there's a whole thing that goes with that. So there's a lot of going in this, and there's a lot of testing that just guarantees that when we even set up these tests, that they actually are set up in a proper way and configured, and they work the way they're supposed to do. So we go through all that. So that will create that, and then it'll set the motion direction of this, so we can actually see this, and now we can come in here, we can look at the particle. I can actually drag it up here, and I can see, hey, this thing is facing east. I can see, hey, this thing is centered in the tube. It has energy, it has a movement per tick, which is its speed. Dimension, it has all this stuff going on, and we can look at all of this really cool stuff, and we can see exactly what is happening. We can go down here, we can check all different things. So I can see that its position did set, I can see the X position set, so I can check and watch it. And then when I come down here to check move line, which is our really, this is when you start to see some of the helper code that does things. Earlier code is not as nice about this, but I got to a point where I realized, hey, I can make methods to test things. And we have a really cool method here, which is entire purpose just to check to see if the particle moves in a straight line. For some of these tests, it's really simple, but it is useful. When we get to the later test, which will start to test a full particle accelerator setup, this method here is going to be so useful, because then we'll be able to tell if it moves through like 20 tubes, all with a single method. So this will check our distance. So it will tell us, hey, we're going to be moving half a block. It'll go, hey, what's our speed? Our speed's 0.1. It'll check, hey, how many steps do we need to go that? We need to take 5 steps. It'll tell me, hey, what's our movement direction? It'll then do some comparison. It'll see, hey, are we at our start position? This is really important to know that we started at the right position, because if we get down here later and we fail, but we weren't at our start position, we'd never know, and then the reason we failed down here is because this was not right. Which is a whole reason behind a lot of these tests, is just to make sure everything's set up right, everything operates right. You got to think of it almost like the scientific method. In school, I don't know if a huge amount of people paid attention to this, but part of doing a scientific test is you try to control as many variables as possible, so you're only testing 1 or 2 things. Usually, preferably, you want to test one thing. That beep was the sound of one of my videos finishing recording. But yeah, you want to test one thing, because that's the only thing you're looking at. You want to know, hey, is this my hypothesis going to work, and my hypothesis is based on this condition? There's a whole mathematical side of that too. There's a hypotenuse testing, or whatever it's called. I believe that's from statistics, where you test like a single variable and you do a whole bunch of statistical analysis. It's similar to this, but in the case of unit testing, you're trying to control all the variables, so you only are testing one thing at a time. Though this actually tests a ton of things. In the case of move line, we're actually checking 5 different iterations of the same method. So when we run update, which you go in here, which will run move, we can go, hey, like how much distance we want to move. We want to move 0.1. This is actually more important than you think, and this is the reason why we actually have to come back here and do more testing, is that as the particle goes through the accelerator, it's going to get faster and faster and faster. The movement per tick is basically the speed. In this case, I'm going to be moving 0.1 per tick. So I'm only going to be able to move basically 1/10 of a block. But this may accelerate to the point where it's moving 5 blocks a tick, which means this code actually has to do a lot more work the faster and faster this gets. The good news is, in most cases, it's not going to be more intense. I'm hoping the performance holds out, but this is another reason for unit testing, is we can check performance, we can check functionality, we can detect for this stuff real early on before it ever hits the player's computer, which is nice. But we can come in through here and we can test things. So we go, hey, our current node, we can check all this stuff. This case is actual logic, so we don't have tests in here. But we can go through movement, and it's got some cutoffs here. Like we know that if we're not moving more than the 0 cutoff, because we can't actually check for 0 due to floating point math. This is something we actually detected through unit testing, is that there was precision error is what it's called. So instead of where you go to add 0.001 to it, and you would think that would be the only thing added, it could actually get off by a little bit just because of how floats are stored inside the memory and operate on the CPU and everything else. So there's a little bit of weirdness with that. So we actually detected that, and that's a bug we fixed early on, thanks to all this. We get down here, and it's going to loop. So part of this functionality for the particle is that we figure out how much distance we want to go, and we're going to loop until we either run out of the distance or our current node doesn't exist, this is a bit of a problem. I actually am thinking about putting a little bit more code in here for sanity checking, because we could run into a situation where maybe not necessarily Atomic Science does this, but maybe another mod adds more tube variants. Like maybe you have a teleporting tube, and the teleporting tube keeps teleporting it back to itself, and you just infinite loop in this little spot, which we don't want to have happen. So there is going to be some detection here. We're actually going to probably put some more stuff in here. We're going to probably say, okay, if we're looping through the same node, which we do have a current node check, but more what I'm worried about is if we're looping between 2 different nodes back and forth. Like say you have 2 forward facing into each other and it's just pushing the nodes back and forth. Luckily the code doesn't allow that, but again, I'm more concerned about mod support than anything else. So this will move, it'll get our current distance, and this will actually do the movement. The movement's done by the nodes right now. This is something I'm thinking about changing still. So this will be a reason why we have unit testing as well, is if we change how this works, we can then actually check if the changes still function the way we expect them. But it'll do all our delta changes, so it'll figure out, okay, where are we from the center? It'll go through and it'll do etc. Like we go through this. I can sit here and debug this. I can watch how this entire thing behaves from start to finish. I can see what steps it goes through, what parts does it check, how does it operate. I can do all of this work, which is really, really cool, is that I can easily detect for bugs simply by having these unit tests in existence. And we can go through and we can see it moves, and we can see how much distance it moved. And then when it moved its single step, it was going to move. We can check for motion changes, which is something that is actually going to be useful in the future, because how we're going to do our rendering is going to be a little funky. Right now we're just rendering blocks in the game, which I'll show up in a second. Consume energy, and it'll do all that. It'll assert that we moved our distance, it'll test movement, it'll go through all its steps, and it'll just sit here and repeat this until we're done. It'll go over and over and over again. And that's how we test our line. Then it'll do the corner change, and then it'll do everything else, which I didn't show off because we don't want the video length being 15 minutes of me talking about one unit test. So this is part of doing all that. And when we get in the game, we can check all this in game, but the cool thing by having all these unit tests, we don't actually have to check it in game as often. So we only need to check it for major releases and everything else. And we know for sure, just by coming in here, that all these unit tests guarantee this code's working as expected, so I can come in here and I can just do a really quick visual check, I can do a really quick performance check, I can check to see if my frame rate's holding out, which it's kind of, there's a little bit of spikes with this. Rendering needs to be optimized and everything else is one of the things we need to get worked on. But we can do all that, and I can just do a really light check. I don't have to do this like full, let's move the pipes in like 50,000 different configurations in the game, which could take me an hour or 2 hours to do. Actually, I can't do 50,000 in 2 hours, but I could do like what you see here would be like about 2-3 hours worth of testing. So I can do all this and everything else, and it can help me tech for a lot of bugs. There was actually quite a few bugs. Like here, we can see the remnants of them. So we had a connection bug that I was working on fixing a while ago, that these weren't connecting properly. And the reason it was happening was that we actually were not detecting how the connections work the way they were supposed to work. So when this reloaded, it wouldn't detect properly, and of course this network needs a little funky, so let me break it and reset it up. So there's some more unit testing that needs to go on to get this set up properly. I'm really hoping this is going to detect a new network, but it's not. As I said, unit testing, more need. It'll eventually reset, there it goes. Kind of. Yeah, this is something I need to work more on, but you kind of see the ideal. So there actually are problems with this, and they're really hard to test in game, because I can look at this and go, oh, it's not working the way it's supposed to, but then I have to go why, and then I have to open up the code and go find the pieces and then debug it internally. I can just make a lot of these unit tests and get them run. So this is kind of a part of the other unit test. So all this stuff is just movement. And we get down in here, by the way, the movement gets a lot simpler, like I was saying earlier, is after a while I figured out how to make this really simple, really effective. So now you have a lot of these single line methods in here, which I've actually even found a way to get around from doing this, and made this actually even more effective in the newer stuff. So now we get the layout stuff. The layout stuff is just what's testing these connections. So you know how like I'm placing pipes and you see the pipes do different things? So if I have a pipe going in this direction, I have a pipe going in this direction, and I have a pipe going in this direction, I expect to see it turn into a T-joint, which it does. This is what all the layout code does, is it checks to see that all of this is working as expected, no matter what rotation we're in, no matter configuration, as long as we meet the expectations of the pipes in a certain configuration, this exact configuration. Because if as soon as we have a pipe here and we break this in places again, it's going to turn into a joint. So there's different configurations based on different things. And when it comes to some people maybe saying it's like, why aren't we just doing what Buildcraft or other mods do and run a whole bunch of wires different configuration? It's a lot to do with the fact these things have arrows on them, and it builds a certain way. The good news is, as a player, all you have to do is make sure you're just placing pipes in a certain order and it works. We don't do updates on certain block placements simply because you as a player may not want things to do with certain things, so we let it be almost entirely manual. I'm going to probably make a tool that's going to let you update these in real time, or do various things that allow it to function different ways. That's a lot of user stuff that needs to be worked on. It has a lot less to do with what we're doing with the rest of this. But with these, they're very simple, very like simplistic tests. And it's nice. It's got a really simple thing. And you can see some of these don't have as much overlap. Some other ones have different varieties of overlap with them. But a lot of these are very basic. We just place tubes in certain directions, we check to see if the connections match, and we do assertion with this. But the thing that got really simplified on this is that I'm working on now, which is the permutation generators, which test different tubes connected to different tubes. So if I have, say for something, an example like this, if I wanted to place an L-bend here, so if I wanted to put like that right there, I can test that this still turns into a joint even though we now have something like this going on. It wouldn't even care no matter how this actually worked. as long as it's set up as a actually, yeah, there we go. So this wouldn't care about this. All that matters is that we have connections, and this is what this does right here. So the layout test this as well, but this goes into much more detail than layout tests do. So this tests a ton of permutations. This is done through a new system in JUnit5, which I just learned here the other day. I kind of knew it existed beforehand, but I've never really toyed with it. And actually sat here and read a little article with it. I'm going to go ahead and pull this up because this is a nice article. I go to the site quite a bit. I don't know too much about them. You can see me looking for images in the last video. But I don't know a huge amount about the site, but they have a lot of information on stuff, and it's pretty good stuff. It's not the greatest of explanations. You can find some better information elsewhere, which is what I did. But it will give you the basics of getting started with it. And one of the things that I've discovered with this is you can do kind of this system of making a single function and then feeding it a whole bunch of arguments and have it run a ton of different tests, which saves you huge amounts of time. So you can run a whole bunch of enum tests. Like say you had like maybe 50 different guns to test, and they were all done via enums. You can test them all via this way. The thing I am using, which if we can scroll down here, there's a ton of different ways. I'm not using the method version, although I could have. The thing that I am doing, which I'm trying to find, is the custom argument provider. What this does is lets me create basically custom arguments that then I feed into a method that then runs stuff. I can do all my expected values and everything else. So in this case, I'm running all the permutations, and which this one is entry. So I'm running all the different permutations of tubes that can enter from themselves into my tube. So like connecting to the back of a pipe. So in this case, like say for example, we had a straight pipe, which is just a normal pipe, and we wanted to test like different connectors. So we want to test that that's going to connect and that's going to work. And we want to test from the other direction. We want to make sure that this is also going to work. And we want to test that if we have a normal pipe and then we also have a join, it's going to work. And then if we have different L tubes, I believe is the other one. Like there's a variety. There's like 15 tests for this that run, and we want to make sure all of these different variety of tubes all connect. And in reality, what the test actually does is this right here. It doesn't care about the rest of these. It just automatically builds this tube in the test and tests it. So it runs through this and it tests everything. And it's got different things. This took a little bit of a while to get working because one of the big things with it is the rotation here. We're not actually saying that we want the front of our tube to connect with it. We want, based on our orientation of rotation, we want us to be rotated forward of the pipe we're connecting to. So in this case, we're doing a split where we want to be rotated to the left. So if we're doing a splitter, which a splitter is done this way. Splitters are a bit confusing to build because you have to kind of do this with them. And we would be testing that orientation, and we want to make sure that this is rotated to the left of it. So in this case, yeah, this would be right. So we're connecting to the left side. We want to be facing right because this is the right face of this tube. Now in this case, this would be the left face of that tube, based on the orientation of this guy, not this guy, which got really confusing. This is one of the things I'm working on, the super permutation. That's going to be crazy, is I'm going to have to figure all that out. But we got all this permutations, and what's really nice about it is I can come down here to the entry, and the methods are really simplistic. So this guy right here runs some like 200 tests. Let me grab a drink of water real quick. Talk for like 18 minutes straight and your throat dries out. But yeah, so this runs a ton of different tests, and it gets all this data. So it gets a facing rotation, a side, and a tube type. So it runs through all that. So it'll give us, this will be our 4 different tests. So each tube can rotate in 4 different directions. So we can have basically this. And we need to test each one because we could have something in the logic where, say, the east rotation is actually facing west. For some bizarre reason, the connecting code failed, and now all of our tests are going to fail because of that, because now, even though it's rotated, say, the opposite direction, it may still be expecting connections on this side, but on this side, it's not going to connect because the tube is now faced the other direction. So it's got some weird but logic behavior with it that could be breaking everything. So we need to test for all that. So it gets all the rotations. It gets all of our tube sides we're going to be testing on. I believe this is what this one is. This one's the rotation. So this will be actually target rotation. It's not named very well. I didn't do a good job naming these. And the tube we're going to test. So what it'll do is it'll build the center tube, which in this case we're only testing normal with this. This is the reason why I actually have to go through and build a super permutation of this one, because the basic permutation we're only testing the normal tubes, which are these little straight guys. So these tubes that are basically your standard classical pipe you see all the time. Then we're adding a tube on the side. So this is the side. You'll then get the facing, do the rotation, and we're going to be placing it on the back side. So it's going to be placing tubes on the back of this. So if we have a tube like this, we'll place on the back. But then it may need to rotate it various directions, it may need to test different things. But it does all that, it goes through all the different permutations, tests everything, and if we run it, I can show you kind of how it functions to some extent. So it'll run 60 tests, 60 different permutations. And what it's actually supposed to show us is all the different test results, but I may have to run this in this mode for it to show me this. No? Really? That's weird. My work computer does this a completely different way. I'm not quite sure how to get it flipped. Oh, here we go. I gotta make it. I have it set up show only the failure mode. But here we go. So to run all this, it'll tell me, okay, we ran all the tests in normal tube measure, which is this class. It'll then say, hey, we ran all the tests in here, and in here we have 60 permutations of test. And it'll tell me each one it ran. It'll run like south, front, corner, right, south, corner, left. It'll run all of this, go through all these different ones. And if for some reason one of these failed, it'll not say that this method failed, which is what a lot of people have a tendency to do before this, is they would just make a single method that then ran through the permutations in a for loop, and then the whole method would fail, and you would have to put print lines or various different things to tell you why it failed, and a whole bunch of information in chat. In this case, I can just simply say, okay, this is the exact test case we're running. We're running south, front, corner, right. And if that failed, I can go, hey, I know exactly what data I was running, I know exactly what conditions this method was going through, and I could quickly sort out what's wrong with my system. So we're doing all that, and we did all the ones for the exit tubes as well. So we have all the entries, all the exits covered on this, and not only are we testing the proper connections on this, we're also testing the invalid ones. So we have 3 invalid tests. We have basically an invalid where we flipped it around, and then we have, or this one's connecting from the back. Yeah, no exit back. So we're testing the opposite side. Then we're testing the 2 invalid cases. So this will be if we're trying to connect from the left and the right into the tubes. So we want to make sure those are also not working. And these 2 basically work in combinations. This one also runs 3 tests, but these 3 tests also cover the same cases. And we run the super permutation, they'll overlap as well. So we'll get like all the different combinations tested, all the different tubes running together, and we'll be able to say for sure that all of the connection logic will work exactly the way it's supposed to work. And then when we get all that done, we can start working on testing the pathfinders, making sure the pathfinder always works, which is the issue we're seeing over here, is that something's not quite right with the pathfinder and causing it to reset. As soon as we come back over here, it's working perfectly fine. Or no, it was this one over here that was broken. You know, the only way I'm probably going to fix this, I'm going to have to break these. These guys are the ones that actually hold on to the networks properly. But if I do a save and quit and reload, it should fix. Because the issue with it was that the pipes connect in the wrong order. Oh my. As soon as I start talking about this, something is causing these guys to update, which is unrelated at all to what we're doing, which is really annoying. I think I know what's actually wrong with it, but another reason for more unit testing. Because right now, the only thing our unit testing do is connections, layouts, and particle movement. So they don't do anything that does anything with this. This guy is like an update connection. There's probably like a chunk border right here. That's my theory, is there's a chunk border in this corner, and that this chunk loads at a different order than this one, and something is triggering it to rerun connection updates, which it's not actually supposed to do. But we'll get to that probably in today's stream here, but I'll see you guys later, and thank you for watching this really long talk about JUnit testing.